Hello everybody, it's Mrs. Pound and I'm back with another video from Chapter 4 on atomic structure from BJU Chemistry's 5th edition. Today's topic is from Section 4.2, the development of atomic models. So we're going to take a look at how the atomic models developed over time, and they have changed. So our objectives are to summarize the discoveries that led to changes in the atomic model, sketch each of the historic atomic models, and summarize the three major subatomic particles, including mass, charge, and location. Now, if you'll remember from the last video, Dalton had an atomic model, but he thought that atoms were just solid, round balls. So that was really the first atomic model, was solid round balls like marbles, okay? He thought that atoms were a lot like marbles, but much, much smaller. Now, Wilhelm Röntgen discovered X-rays, and he didn't propose an atomic model, but this is important to know because X-rays contain charged particles that were important in making discoveries about atoms, as we will see when I talk about some of the experiments. The first model after Dalton's model was Thomson's model. And Thomson worked with cathode rays. So this is a cathode ray tube. And you can see that the light is going in a straight line. Um, and what he did with these cathode ray tubes is he discovered that the rays going through, because they're not affected by gravity, must be either waves or very fast moving particles. So he started to experiment with these and he put a magnet around it and he discovered that a magnet could deflect the ray. And so he concluded that they're really fast moving particles and he wanted to see what kind of particle it was. So what he did is he put charged plates on either side of the tube. And what he discovered was that the rays bent toward the positively charged plate. And so what he concluded is, remember, like charges repel, unlike charges attract. Since it was attracted to the positively charged plate, it must be made of negative particles. So he concluded that every atom contains small negatively charged particles, and we call those particles electrons today. So an electron is a negatively charged subatomic particle. And Thomson's model, you see this in the background. I want you to write this off to the side. Have a picture of this in your notes next to Thomson's name. It's also called the plum pudding model, because he pictured it as plum pudding, which had a positive overall charge with negative raisins in it. Plum pudding is an English dessert. It's like a cake. It's not what we would consider a pudding, but it's more of a cake with raisins in it. And so he pictured the atom as being a positively charged cake with raisins in it that are negatively charged. So make sure you get a picture of this in your notes. Now, the significance of this was that he discovered electrons and concluded that atoms can be subdivided into different particles, that they're positive and negative. He didn't know about the positive particles yet, but he did know that you could take negative particles out of it. Then came along Rutherford's model, and this is where X-rays come in because his assistant Hans Geiger worked with alpha particles and gold foil. So what Hans Geiger did is he had an alpha particle emitter, a radioactive material, and he passed that through a slit and aimed it at gold foil. Now, what he discovered was most of the alpha particles went right through the foil and hit the detection screen on the other side, but some bounced back. Okay, so over here, if we look at these two pictures, this would be Thomson's plum pudding model. If Thomson's plum pudding model was true, all of the rays just would have gone through. But what Rutherford concluded, due to Geiger's experiments, was that atoms are mostly empty space with a hard positive center in the middle that caused those alpha particles to bounce back. They were deflected. It must be positive because alpha particles are positive, and it was deflected backwards. It was repelled. It was not attracted. So Rutherford proposed that there was the nucleus, a small region at the center of an atom that is positively charged. As we can see in this model in the background, there is this nucleus. Now, this nucleus contains both protons and neutrons. We'll talk about the neutrons a little. Rutherford did not discover the neutrons, but he said there was this nucleus with the electron around outside. So go ahead and next to Rutherford's name, draw this model with the nucleus and the electrons. So it contained protons. This is a positively charged particle in the nucleus of an atom. And he also, from the protons, we get the atomic number. This is the number of protons in the nucleus of an atom, and it determines the atom's chemical and physical properties. So every element on the periodic table has an atomic number, and that tells us the number of protons in the nucleus. So the significance of this is that there's a positively charged protons are found in the nucleus of an atom. Now, along came James Chadwick, and he changed Rutherford's atomic model to include neutrons. So here we see protons, neutrons, and the electrons around the outside. Neutrons are a subatomic particle in the nucleus of an atom that contributes to an atom's mass, but not its charge. So it was discovered that the nucleus was more massive than just the protons allowed. And these were not detected for many years, the neutrons, because a neutron is electrically neutral, making it very difficult to detect. It's easy to detect charged particles because they are attracted and repelled to like and unlike charges, but a neutral particle is very hard to detect for that reason because it's not attracted or repelled. And the significance is that he discovered that neutron, which accounted for extra mass in the atomic nuclei, because they were heavier than expected. So, a summary of the discoveries. First, all atoms contain electrons, protons, and neutrons. Electrons orbit the nucleus, which contains protons and neutrons. Electrons are negatively charged and have about 1/8000th the mass of a proton or a neutron, so they're very small. Protons are positively charged and have slightly less mass than neutrons that are electrically neutral. So our objectives for this video were to summarize the discoveries that led to changes in the atomic model, sketch each of the historical atomic models, and summarize the three major subatomic particles, including mass, charge, and location. So don't forget to write your 5 questions for this section, and I'll be back with another video.